This is question 2, where we're analyzing rational functions, trying to find the horizontal asymptote, the vertical asymptote, the y-intercept, and the x-intercept. And it's helpful to just do a little bit of pre-thinking about this. The horizontal asymptote, you have two possibilities. One is, at least for the purposes of this test, one is where the degree of the numerator up here and the degree of the denominator are the same. So let's just rewrite or think about any rational function. A rational function has a numerator, we'll call that n of x over d of x, where d is the denominator. So in this case, the degree of the numerator in problem 1 is 1. It's to the first power. And the degree of the denominator in this condition, or in this problem, is also equal to 1. Now, for the purposes of the horizontal asymptote, if the degree of the numerator is equal, degree of n of x is equal to the degree of the denominator if that's true, then just look at the leading coefficients, and the horizontal asymptote will be y equals the leading coefficient of the numerator over the leading coefficient, let's put an n there, over the leading coefficient of the denominator. And what I mean by this is you just look over here. It's just 3 over 1. So the horizontal asymptote in this first one, this is really the hardest. It's a rule that we could explore, but it's just a rule that if we get really big numbers, the x terms overtake the 1 over 2. So like if I put in 1,000, it's going to be 3,001 over 1,002. And we get 3,000 approximately over 1,000, or about 3. So in that first one, it's going to be y equals 3. That's the horizontal asymptote. If the degree of the numerator is less than the degree of the denominator, then the denominator, like right here in the second one, gets really big as x gets larger, or even smaller. It gets to be huge, like 4 over, if we think of 1,000 squared is 1,000,000. 4 over 1,000,001 is nearly 0. So if this is the case, then the horizontal asymptote, anytime the numerator degree is less than the denominator degree, the horizontal asymptote will just be y equals 0. The graph will just approach the x-axis, y equals 0, but it won't cross. Those are the two rules that you just need to know. Of course, the numerator degree can be larger than the degree of the denominator, but then we don't have a horizontal asymptote at all. We have either a slant asymptote or something much more complicated. So these are the only two rules you're responsible for horizontal asymptotes. Now, vertical asymptotes To find vertical asymptotes, you set the denominator equal to 0 and solve for x. And so in this case, we're looking up here. And let me see if I can do something here real quick. Just take that off. So the denominator is x plus 2. So we've got x plus 2 equals 0. And so subtracting 2 from both sides, we get x equals negative 2. So this will be what we say, y equals 3. It is a line, so we need to write it as the equation of a line. The denominator will be x, or for the vertical asymptote for this function, it'll be x equals negative 2. To find the y-intercept, we just, the y-intercept is the value when the function, when x is 0, so we just plug in x, plug in 0 for x, or in this case we'll just say, what's f of 0? Well, that is 3 times 0 plus 1 over 0 plus 2, which is 0 plus 1 over 0 plus 2. You get the idea, it's just 1/2. That's the output. So the point here, a y-intercept is a point, it's 0, comma, 1/2. And then for the x-intercepts, well, the x-intercepts are the value of x when the function is 0. Now the function is 0 only when the numerator is 0, so long as the denominator isn't also 0. So to find the x-intercept, we solve, we set the, we say numerate the numerator, n of x, we solve n of x equal to 0. Just find out when the numerator is 0. And in this case, 3x plus 1 equals 0. Subtracting 1 and dividing by 3, and I'll just say, well, that's x equals negative 1/3. So this is negative 1/3, comma 0. Now, this is a graph of this function, and you can see the graph has, if we look at the y-intercept, it's 0, 1/2. We look at the x-intercept, it's negative 1/3, 0. The horizontal asymptote is y equals 3. Vertical asymptote is x equals negative 2. And you can kind of see that visually there. Okay, let's quickly do the others. Here, let's apply our rules when we look at, let's use a different color here. So when we look at the leading coefficients, this is 1 down here, and you'll notice the degree of the numerator is 0. The degree up on top is 0. Down below, the degree is 2. So the degree of the numerator is less than the degree of the denominator. So we're using this rule, and that's our answer. Y equals 0. The vertical asymptote is when, and that's looking at this, set the denominator equal to 0 and solve. Now, the denominator x squared plus 1 equals 0. A bit of thought, we can solve this, but a bit of thought tells you there is no solution to this because there's no real solution. So let's just write none. There's no value of x, no real number x that will make that denominator 1. The y-intercept. Now again, what do we say about the y-intercept? Well, we set the function equal to 0 and solve. So for the y-intercept, let's say, well, what's f of 0? It'll be 4 over 0 squared plus 1. That's 4 over 1. 4. So this is 0, 4. Kind of crappy 0. And the x-intercept is when we set the numerator equal to 0. I'm sorry, yeah. Set the numerator equal to 0. That's what we did over here. 4 equals 0. That can never happen. So there's no x-intercept. Let's take a look at this graph. This would be this one. So this is what this looks like. You can see the x or the y-intercept is 0, 4 for our function. There doesn't appear to be any vertical. In fact, there's no vertical asymptotes. There's no x-intercepts. It just approaches. If I keep coming out here, it approaches 0, but never crosses. So that's, and the same going to the left. So there's no x-intercept. Finally, for y, I guess I said that, y-intercept 0, 4, no x-intercepts, no vertical asymptotes. The horizontal asymptote, though, is y equals 0. Y equals 0. This function right here, or this dotted line down here. So hopefully that helps on that one. Let's take a look at our final problem. The horizontal asymptote, you notice degree in the numerator, degree in the denominator is the same. So we look at these leading coefficients. That's 3 over 1. So this is y equals 3. Let's go back here. It's y equals 3. For the vertical asymptotes, there we set the denominator equal to 0, x minus 4, x squared minus 4 equals 0. We'd add 4 to both sides. X squared equals 4. Take a square root of each side. Plus and minus. So we get x is equal to plus or minus 2. So we have 2 vertical asymptotes. X equals negative 2. X equals positive 2. The y-intercept is when we set the function equal to 0. Clear this off a little bit. So the y-intercept is f of 0 which would be 3 times 0 squared over 0 squared minus 4. Well, that's 0 over negative 4, and that's 0. So the y-intercept is 0 when x is 0. 0, 0. The x-intercept, we set the numerator equal to 0. And we just say, well, the whole thing is going to be 0 when 3x squared is equal to 0. Well, 3, if I divide both sides by 3, I get x squared equals 0. Of course, I can take the square root of both sides, but that's just x is equal to square root of 0 is 0. So when x is 0, I'm sorry, what we're basically saying is when y is 0, x is 0, it's the same point, and that's our answer. Let's do a real quick verification on that and take a look at this graph. Excuse me. Take a look at that graph. That was 2c. Is it this one? No, this one. No, this one. I thought I had this. There we go. And here you can see these two. This is the graph up here of 3x squared over x squared minus 4. You see some vertical asymptotes here, positive 2 and negative 2, and a horizontal asymptote at y equals 3. Kind of an interesting looking graph, but we've analyzed it properly. We've got it. Okay, hope that helped.